teaching math 2. And the student was a student at the middle school across the street. And so he was so accelerated, especially in his math. I mean, he was out there. So they had done what they could do with him in the math at the middle school. They thought, hold on, we're going to send you across the street to SMC. And since the school hours are, I think school dismissal was around 3 o'clock, 3:30. So I was teaching this class at 5 o'clock like I am with you guys. And I was very fortunate to be the professor who got this kid at 5 o'clock, middle school kid. And so when I was taking the roster, like today, I called your names, it came up. When I called his name and he came up, I thought, he must have gotten the wrong room or something. I thought he belonged across the street, but he's so small. So I didn't say anything, I just called his name. His name's on my roster. I said, welcome. And he took the syllabus and took everything else. And then I thought, no, I've never had a student this young. This kid is young. Taking a pre-cal course from the middle school. And all he did, he sat in the back, didn't say one word all semester. All he did was sit there and watch. Did not take one note. Just watch. I thought, no, I think those middle school people are crazy to send this kid over. I don't think he's doing nothing. They sent him over to me. And I don't know how old he was. I'm 10 years old or whatever. I don't know how old he was. He looked very young. I said, no, that kid, no. He just sits and watches. Doesn't talk. Just watches. And when class is over, he just gets up and walks out. I don't think I heard his voice. And this was consistent. Mondays and Wednesdays, Mondays and Wednesdays, Mondays and Wednesdays. And then finally the exam came up. The exam day I said, oh, I'm going to score his first. And I start scoring papers. I said, oh, that's something strange going on here. This kid, he's not taking notes. He's not asking questions. So I scored his first exam, perfect score. I said, hold on. A 10-year-old kid. Okay, so waited a little bit longer. Then the second exam came up. He never missed. He was always here. And it was perfect. Second exam, I thought, well, I'll score his first again. Let's see what this kid's doing at 10 years old. Perfect score. So we had, let's say we had 5 exams like you guys are going to have. All 5 were perfect. Did he ever say anything? Never. Not a word. Not a word. Now, could he have, knowing him, and I don't know where this kid is now. I don't know whether he's out doing great things, I hope. Now, he may have finished this up. I couldn't have. But he may have finished this up. Who knows? I can just imagine. Can you imagine as I'm calling the names, he's up back there working this out, and all of a sudden, I'd say, did anyone finish this up? And the hand goes up. Perfect score. So he made a perfect score on all. And then finally, the final exam, no one had ever made a perfect score on my final exam. Not until that point. I thought, oh, come on. No one's ever made a perfect score. Some high scores, of course, on the exam, final, but not a perfect. Opened his up, scored that 10-page final, perfect. Perfect. And the last day of class, he just walked by and didn't say anything, didn't say goodbye, didn't say anything, just that's the way his mind operated. Just left and where he went, I don't know. He had all his perfect scores. So guys, it can be done. It can be done. Now let me ask you this though. If we emphasize, break is supposed to be 6:10, guys. We've got a 10-minute break. If we emphasize only solving equations, because it took a big chunk of my time on the syllabus and so forth, I see some that are quite simple, and I see some more demanding. So if a professor had presented some of these equations to me the very first day and said, here's your quiz, I'm giving the quiz the first day, then I think I would have been shocked. I think I would have been shocked. I've solved equations, you've solved equations before. So the very first day of class, and all of a sudden you're thrown and asked to solve an equation. Now some of these equations look like they're a little bit crazy. first. Now, in the little time I have, I'm gonna do this. I'm gonna choose a few of these, and I have a few more of my own, but right now, before break time comes up, let's see if I can get this organized for us. Part one, let's say solve an equation. And we'll just take a look at a few. Get started. And then we'll get some input. Who knows, the student may have tried this. Guys, I'm going down to this one. That's a 1/2, looks like there's a K there. Subtract 4 equals 3/4 K. I think we should solve for K. What's the value for K that would satisfy that equation? Now, I need some input from you. This is the first day. And I know how students are, and how I was. We may have different methods on how to approach a problem. Does anyone have a suggestion on how would you approach solving for K with that problem? I hope I have it copied down correctly. Any suggestions? And I'll try. Is it copied down correctly, by the way? Any suggestions? There we go, yes.
Subtracting 1/2 K both sides.
I could go and move that over. Look at this guy. She says, Professor, go ahead and do this. This is her method. And over here. So she wants to get those K's together. Of course, they would drop out there. She's subtracting 1/2 K from both sides. That's going to leave her, now, it's going to leave her on the right-hand side fractions. So she's going to put together 3/4 K, another like term, negative 1/2 K. How are you going to put those two together? They're fractions. What does one use to put fractions together? What am I looking for here? Yeah, something I know. I'm looking for a word here, or a couple words. A common denominator. I can't put them together unless there's a common denominator. What could I use for a common denominator for 3/4 and negative 1/2? 4. So I could rewrite, hold on now. She's going to help me here. This is 3/4 K. I will leave that has the 4. Now, can anyone tell me what would negative 1/2 K in the red? I've got to change it so it would also have a denominator of 4. Well, you said, Professor, is missing something. And what's missing is, to change it to a 4, multiply the bottom denominator and the numerator by 2. Would that now change that denominator to a 4? And could I now think of this as negative, what is that? Negative 2 over 4K. If I do that. Is that true now? Now, are they more alike now? Put them together, 3/4 K, subtract 2/4 K. Guys, what can I say now on the right-hand side? What's the result of these two put together? Is that 1/4 K? Yes, no?
Yes.
Okay. Now we're down to here with her help. Now what? We still don't have K by itself. What would you suggest now? Go for it.
You multiply by the reciprocal of both
If I multiply by the reciprocal, and here you say the reciprocal of that 1/4, because I'm after K. If I flip 1/4 over to form a reciprocal, she's saying multiply both sides, Professor, by 4 over 1. 4 over 1. And why? Because she wants these 4's to cancel, which they will. The 1's will cancel. Finally, that leaves K by itself. The other side, final answer is, what's the other side? Is that negative 16? A negative 4 times a positive 4? And you end up with this? If there's no mistake. Did anyone try this one? Did you get negative 16? And who knows, you may have gotten negative 16 by doing something else differently than what she suggested. But I like what she suggested. Now, I know this is Math 2 pre-calc. Now, you're going to take that much time to do that little simple problem later on in this course? No. You're going to zoom right through it and get the answer. But at least there's a method there to look at. And one more here. That's all. Let's call this part B. And I'll need some input for this one. See who might get this to work out. Here we go, guys. Now I'm jumping into it. I'm going to do some work after the break. I got x cubed is equal to 16x squared. A variety, a little variety of equations here. All of a sudden you walk into USC and USC says, solve this problem. UCLA says, solve it. And that's all they say is those universities, solve it. Any suggestions how to do this one?
There's two answers.
Do it again.
There's two answers. One of them can be zero.
So one of the answers can be zero.
Yeah.
Okay, look at this. She said, Professor, I see right now, I'm just staring at it, I haven't solved it yet, that if you replace x by zero here, what is zero cubed? 0 times 0 times 0, is that 0? And she said, if you replace 0 on the other side and square it, is that 0? 0 squared, then times 16, does this remain 0? Would that satisfy both sides? So one of the answers is 0. The trouble is, and I like that, one of the answers is 0. I will tell you ahead of time, there are two others. Now what might alert me that there might be two others? She's given me one just by guessing and it worked. Now can anyone tell me why is Ramsey saying there's two others? Yes?
Well, maybe I did this wrong, but if we have x squared on the right side and the other side is x to the cube, then one of my answers also just must be 16. No? Am I wrong?
Oh, I got you. Hang on. So you're saying replace 16 here, so that means 16 times 16 times 16.
Yes.
A big number.
Yeah.
On this side, if I replace 16, it's 16 times 16, that's 16 squared. And there was a 16 to begin with. So does that give me again 16 times 16 times 16 the way he reasoned? Again, where the two sides match up. Another answer is 16. Her answer, 0. There's one more answer. Let me step back and make sure we're looking at it correctly. Or they may be the only two. Now, I haven't touched it yet. I haven't touched it myself to show you the algebra involved in solving this. I got 0, and we checked it. 16, I love what you told me about 16. 16 works. Now, does anyone have a method to find out those two, or find or solve those two, and get those two answers? What would you do? If you had to show your work, go for it. Okay, you want to subtract 16x squared. In other words, you want to move this over. And for some reason, which you can move it over if you wish, at least you got the x's together. He says, just move it over, Professor. Now, before we take a break, does anyone see anything that I can do, and be very careful, on the left-hand side with what he told me to do? And it's screaming at you to do it. What are you going to do with those two terms that are together on the left? Which is going to take me right into my lesson after the break. What are you going to do? Yes? Factor. There's that word coming in after the break. Now, factor, I don't know how many students remember factoring. I hope we all do. What type of factoring might you do first on the left-hand side? And it's looking at you like, please do it, because it's so obvious something's going on the left-hand side you should do first. Does anyone have an idea of what on earth is it? And she wants me to factor. Do both those terms contain something in common? Is there an x in the first term?
Yes.
Is there an x cubed in the second term? Can I take that common factor, which is x? At least there's one x in both. Can I take that common factor out? And guys, when I take it out, I gotta be careful. I'm jumping right into it. What's left over? It's going to be x squared minus what? Or can I take out more than just x? Can I take out more than just x? It would be helpful if I take out the most. What can I take out besides just an x? X squared. Now if I take x squared out, and I'm careful here, you're going to end up with x subtract 16 is equal to 0. Now my students have already given me the answers. Now if I split this up, you can set each one of these factors at this point equal to 0. It's called the zero product property. That makes sense that one of those has to be 0. So I'm going to look at both of them. This guy's obvious here, x must be 0 for x squared to be a 0. This one, move the 16 over, add 16. Do I get the 16 that was mentioned? And those are my answers. 0, 16, with the algebra there to show what happened and how to get it. 0 and 16. Therefore, take a break. I think there should be 3 answers. Now, can someone, on this very first day, I'd be impressed, tell me, Professor, I see 0 and 16. Your students guessed at those, and you show us how to get them algebraically. Professor, how do you know there's another one? How do you know there should be 3? What do you think gives it away, just the way it looks, to say, don't stop, there should be 3 answers here? Yes?
Wait, should I say the third answer?
Tell me, oh, you got a third answer. What do you think it is?
I think it's -16.
Now, hang on just one second. So if I put a -16 right here, and I cube it, I'm not going to actually multiply it out, but -16 times -16 times -16,
It's a negative.
it's going to give me a negative answer. Negative times negative times negative. So the left-hand side will be a negative big number. If I put a -16 here and square it, what happens if I square -16? It turns into a positive times that positive out front. So I'm going to have a negative on the left and a positive on the right. They will not match up. Can anyone tell me what is wrong here? Did Ramsey do the algebra wrong? I got 0 and 16 when I did the algebra. My students guessed 0 and 16, and I'm saying no, there should be 3 answers. First, how would I know there should be 3 answers? Before we jump into all this after the break, how do I know just the way it looks? Professor, I think I should get 3 answers even before I start. What gives it away? Yes.
Is it the x cubed?
It's the exponent. The highest exponent. And I'll give a name for this. The highest exponent is known as the degree. So my degree gives it away. So there should be 3 answers. I have only 2 numbers listed. Can anyone tell me where's the 3rd answer? He thought it was -16. -16 is not going to work, but that was a good guess, but we tried it, it would not work. What's my 3rd? Where is my 3rd answer? And I'll give you a hint. If you had this in your textbook and you check the answer in the back of the textbook, more than likely the textbook will have only these 2 listed. But there should be 3 answers. Does anyone know what the 3rd one is? And why? And why would the textbook just list 0 and 16 and be satisfied with it and move on? If you just have 0 and 16, move on, you're okay. Why might I, before I take a break, why might I really have an understanding that I have those for the answers? I have the 0 repeating. It's acting as 2 answers. Now, do I have 3 altogether? But usually if one repeats, we just list it once. With the understanding, in this case, it really acts as 2 of the 3 answers. Now I've got 3 answers, 1 repeats. Now what back here tells me maybe, let me look at it here, somewhere in here, that maybe, in the red there, that maybe 0 acts as 2 answers. What might give that away? Yes?
X squared.
There you go. That's what I want to hear. Marker will work out for me. Said, she's telling me, Professor, that exponent on the x squared tells you just for it to expect 2 answers. And when I solved it, I got what, 0? But really it's what? 0, 0. It's supposed to get 2 answers. And therefore, altogether we get 3 answers. And guys, that was a big, long story about it, though. But if I got down to here, I'm happy. I just want to confirm I do have 3 answers, though 1 repeats. Okay. Now, look at the clock here, 6:10. We got a 10-minute break. Now, when I say a 10-minute break, I mean we're going to be back here at 6:20.